Hey folks, as you can see, I'm not here today at school, so you're going to be watching this video and taking notes along with it. Every so often the video will stop and ask you a question, just answer it, and that's how you're going to get credit for watching this video. So let's get started. First, let's just remember the stuff we've learned about logs and exponentials so far. Kind of the main technique that we've been looking at is that if we have an exponential, that we can rewrite it as a logarithm. So if we have a to the x power equals b, we can rewrite that as log base a of b equals x. Remember, the logarithm will always equal the exponent. So we're going to use that a little bit today, but we're going to mainly get into properties of logarithms. So I offer you those three properties right there: product rule, quotient rule, power rule. They do come from, if you remember, exponent properties at all from Algebra 1. They come from the fact that, say, if I had a to the m times a to the n, that was m plus n. That's why we're adding. Multiplying inside the log turns into addition. The exponent rule around division was if I were dividing the same bases, I would subtract the exponents. So in this case, when I see division inside the log, notice it turns into subtraction. And then this power rule has to do with in exponents when you would do like power to a power, you would multiply the m and the n. So how that looks here is this little r, this exponent of r kind of comes down in front, and as you can see is multiplying by the log. So I'm going to look at some simpler problems first with you, and before I get into some meatier ones that use these properties. Now, some of the problems I'm going to do now, we could have done in class together last week, but we want to really illustrate these properties. So know that there are other ways to do some of these. I'm just using the properties you were just given in order to have you work with them a little bit. So for number one, I have one thing I notice is they're both log base 2. That's great. What that means is I can push those two logs together because they have the same base. So I'm going to highlight that, the same base. So what that means is I can use my quotient rule. The reason I'm picking quotient is because of the subtraction sign. So if I push these two logs together, the 24 is going to get divided by the 3. It's still a log base 2. And I can do 24 divided by 3. That's just 8. And now this should feel like a problem from last week. This is really saying 2 to what power gives me 8? Well, that's just 3. So what looked really complicated, that log base 2 of 24 minus log base 2 of 3, is just 3. So you're going to see me doing that for a lot of these just to illustrate the properties. All right, next property that we're going to look at is power rule. See how there's the 2 down in front? I'm going to bring that up. So I'm kind of using power rule backwards. I'm going to bring that up as an exponent. So this is log base 36 of 6 squared. So basically log base 36 of 36. Wow. So what is this saying? This is saying 36 to what power gives me 36? That's just 1. So right now your head might be spinning a little bit. You might be like, what is Sid doing to us while she's not here? Know that properties usually take a little bit to understand, and we will definitely be reviewing them when I come on Thursday. So let me keep going with some of these, like I said, easier, smaller problems just to sort of illustrate what's going on. So in class on Friday, we probably could have done number 3 a different way than what I'm about to show you. So I want to really focus on these properties. I'm going to try to take apart this division. So I'm going to do that by doing log base 5 of 1 minus log base 5 of 125. So I just pulled that apart. And now I have two kind of smaller problems here. This is saying 5 to what power gives me 1? Oh, that's 0. And this second log is saying 5 to what power gives me 125? Well, that's 3. 0 minus 3 is negative 3. All right, so if this wasn't hard enough, let's do some ln work. For number 4, even though I see two logs being added, I notice they're different bases. Remember that when I see ln, this is base e, so that base e and base 4 are not the same. So I can't really just push those two logs together. I actually have to do a little bit of work separately. So it looks like this one is not good for the properties because they're different bases. That's okay. So let's just deal with them as sort of separate problems, and then we'll add at the end. This first part is saying e to what power gives me e? Well, that's just 1. And then the second part is saying 4 to what power gives me 16? Oh, well, that's going to be 2. And 1 plus 2 is 3. All right, just a couple more, and then we'll get into kind of a different type of problem around the properties. So for number 5, I have two different logs, and usually I want to try to push them together if they're two different logs. I see that they're the same base. Even though it's not written, these are both base 10. So the fact that they're the same base means I actually can push them together. Before I do that, I have to bring these numbers out in front up as exponents. So I have log base 10, although I don't write the 10, of 3 to the third minus log base 10 of 9 to the 1/2. Okay, so 3 to the third, that's 27. 9 to the 1/2, well, think of this as square root of 9. So that means this is going to be log of 3. Well, now I can push these two logs together. Subtraction means I have to divide on the inside. And so this is going to become log of 9. Now, we could go further and say like 10 to what power gives me 9. There's no nice number for that, so we're going to leave our answer like that. Which feels a little weird considering we've gotten answers of like 3, 1, and negative 3. But sometimes we just can't fully simplify, and that's okay. All right, last one on this page. Again, this is like a base E. This is base 10. Okay, so two different bases mean we can't push them together. So we're going to deal with this one kind of like we did number 4. So let's bring numbers up so that they're exponents. So ln of e to the 4th plus log of 10 squared. All right, so two little problems. This first part is saying e to what power gives me e to the 4th? Oh, well, that's 4. And the second part is saying 10 to what power gives me 10 squared? Well, that's 2. And 4 plus 2 is 6. So before I leave this page, I wanted to let you know the reason I could push number 1 together is because the bases were the same. Same thing with number 5, bases were the same. But in 4 and 6, the bases were different, so I couldn't push them together. All right, so let's take a look at some different ways of using these properties. So for number 7, before we start looking at these, I want you to know what I call these. These are called take them aparts. And that's because we want to take apart as much of the logs as possible. We want to write them in as many different logs as we can. And here's the order in which we usually approach the properties. So the first property I try to use is the quotient property. Then, not the power property. Shoot, it's getting too excited there. Then the product property, and then the power property. So that's in the order that I tried to use them. And let me illustrate that with letter A. So the first thing I try to do is get rid of the division. The property says that if I'm dividing, I can rewrite it as two logs that are subtracted. So that means I have the ln of xy minus ln of z. So now I've used my quotient property. Next up is product property. Well, I have multiplication going on between the x and the y, so I can break that apart. So this is ln of x plus ln of y minus ln of z. Now, how do I know if I'm done? Well, I look inside the x, y, z, like the inside the logs, and I see no multiplication, no division, no exponents. So this would be fully taken apart. All right. Our next one, we want to take it apart into many as logs as possible. We don't have any division, so no quotient property, and there's no multiplication, so no product property. All we have to do is power properties. So that 1/3 comes down in front. I look inside my log and I see that there is no multiplication, no division, no exponents. So that is my final answer. So depending on what we're dealing with, that final answer could feel kind of easy. All right. Letter C has a new twist to it. So want to remind you that when the base is not written and you see log, it's base 10. So this is log of 100. I'm taking apart this division minus log of x to the third. Now there's no multiplying, but there is a power. So log of 100 minus, I'm going to bring that 3 down in front, 3 log of x. So this feels like it should be done, right? We don't have any more division, multiplication, no more exponents. But it's not quite done. Here's why. That log of 100 can be simplified further. That log of 100 is saying 10 to what power gives me 100? Well, that's just a 2. So now we have 2 minus 3 times log of x. Don't subtract the 2 and the negative 3. That violates order of operations. You're saying subtraction is more important than that multiplication. So that is our final answer. So that was the new twist. By the way, if that 100 was something like a 90, I wouldn't have done that. I would have just kept it as is. But the fact that 100 is a power of 10, I'm going to go further. So maybe right now you want to pause and see if you can do part D. So take a look, pause the video and see if you can do part D. All right. So hopefully you're coming off the pause and you're saying, hey, I kind of got it, or I got stuck. So let's see. First step is to undo this multiplication. So log of 10 plus log of square root of x. There's no division, so I skip right over quotient property. Okay, next up is that square root. Maybe you ended there, but remember, square roots are exponents. So that's an exponent of a half. So that 1/2 comes down in front and multiplies the log. Now, if you could get this far, I'd say give yourself a pat on the back. There's one more step though. Just like in the last problem, log of 100 can get simplified, so can log 10. Log 10 is saying 10 to what power gives me 10? Well, that's just a 1. So this is going to be 1 plus 1/2 times the log of x. Again, that does not give us 1.5 log of x because multiplication is more important than addition. All right, so let's get this last taken apart problem done. It's probably the most rigorous because there's lots of parts to it. So I see 1, 2, 3, 4 parts that need to be pulled apart. And this is important when you go in order. So first up is quotient property. So log base 2 of 2 root 3 minus log base 2 of 5p. Okay, now that we've taken apart quotient property, we need to break apart this multiplication here and here. So log base 2 of 2 plus log base 2 of root 3 minus log base 2 of 5. And I'm going to put parentheses here, plus log base 2 of p. Now, the reason I put it in parentheses is because both the 5 and the p were originally in the denominator. So this minus sign is going to apply to both those terms. Now, if you're following me so far, that's great. I'd say there's 2 more pieces we need to simplify. One of them is this log base 2 of 2. That's problematic. This is saying 2 to what power gives me 2? Well, 2 to the first gives me 2. The other piece is that the square root is an exponent. So we need to bring that square root or that exponent down in front. So we get 1 plus 1/2 log base 2 of 3 minus, and now this, you can leave this as your final answer. Or if you want to distribute that negative, that would just make this last term negative. But I'm going to box this as a final answer because I feel like that was plenty of work. Whew, those take them aparts, they can get hard. So now let's talk about put them togethers. So let me write another. So these are put them togethers. So we try to mush them. As far as the order of the properties, first we're going to do power property, then kind of at the same time quotient and product. All right, there's only 3 of these, so not as many, which is kind of nice. So let's take a look at what we got here. So first thing I need to do is bring up any numbers in front of the logs. There's no number in front here, but there is here. So this is going to be ln of x minus 2 minus ln of x to the third. Now you might be saying, well, hey, why don't you just bring up the negative and the 3? You could, but then you have a negative exponent. You need to know what to do with that. So I would suggest just bringing the number part and leaving the negative back behind. All right. Now we have these 2 logs being subtracted. They are the same base, so we can push them together. Subtraction means that we're going to divide what's inside. And now we're writing it as a single logarithm, so it's all pushed together. Sometimes those feel a little easier for folks because you kind of know when you're done. you can see it as 1 log. So this might be a good time to press pause again and see, can you get like a first or a second or a third step on part B? Okay, so hopefully you're coming off of a pause and you brought that 3 up first. We need to deal with that power property before we do anything else. And while I'm finishing writing that, I noticed that they're both log, L-O-G, so both base 10. So I can do this, I can actually combine them. All right, in the next step, I'm going to do two things. I'm going to combine them into one log with multiplication, and I'm going to write 2 to the third as 8. Now I get 8 times x minus 1, so that's going to be 8x minus 8. So fully simplified, it's the log of 8x minus 8. All right, one more of these, put them together, and then on for something just a little bit different before I let you go. All right, first step, maybe you want to pause and take that first step on your own. So coming off the pause, your first step should be to move that 3 and the 1/2 up. Okay, so we have log of 3 to the third minus log of 9 to the 1/2. So let's deal with some of those exponents. Again, noting both logs of the same base. So we can actually do this. 3 times 3 times 3 is 27. Square root of 9 is 3. Okay, now we can push together these logs. Subtraction means I'm going to divide the 27 by 3. And that is just log of 9. It makes it look so much nicer, and yet it was so complicated. We're definitely going to practice these on Thursday more, and obviously they're going to come up in your homework. Now there's a couple other types of problems that practice this. So I definitely want to have these in the video for you, but if you're feeling overwhelmed, this might be a place to stop and just say, you know what, I'm going to watch the rest of this later. But if you can hang in there, I would say let's do definitely number 9, and then we'll see how number 10 feels. But I think they have kind of a nicer feel to them. Okay, so these are kind of interesting. They're saying don't use a calculator. Just use the fact that log of 4 is 0.6 and log of 8 is 0.9. So what that's really telling me is I want to rewrite everything with a log of 4 or a log of 8. So 32 is a kind of a great number to start with because we can think of 32 as 4 times 8. And now let's swing back to those properties. We can pull this apart as two different logs. This is log of 4 plus log of 8. And now I'm going to use these substitute in these values. So log of 4 is saying that's about 0.6, and log of 8 is about 0.9. So 0.6 plus 0.9 is 1.5. Maybe that feels a little easier than what we're doing. All right, so next one, I'm going to pull apart that division. So remember, when we divide, it turns into subtraction. So log of 4, well, that's 0.6 according to this problem, and then log of 8 is 0.09. So if I subtract 0.9 from 0.6, I have negative 0.3. All right, the last one here kind of depends on what you see first and how you want to write the 64. I think it's a little more natural for me to think of 64 as 8 squared, but you can certainly think of it as 4 to the third if you want to. So I'm going to go with the 8 squared. Power property says bring the 2 down in front. And so log of 8, I'm told, is 0.9. So 2 times 0.9 is 1.8. All right, let me finish up this last page with you. And again, these may feel a little bit better and more reachable for the properties. So same idea, just different values. Here I'm working with log of 3 and log of 5. So let's get going. Log of 15. Well, if I'm only allowed to use 3s and 5s, this is going to be log of 3 times log of 5. So that's going to be log of 3 plus log of 5. And now I'm going to substitute. So 0.5 plus 0.7 is 1.2. All right, division means this changes to subtracting 2 logs. So this is 0.5 minus 0.7, so negative 0.2. And our very, very last problem, 45 is not as nice as the 15, is it? So again, we want to break up into 3s and 5s. Let's think of this as log of 9 times 5. So a little bit of a variation on part A. So this is log of 9 plus log of 5. But the 9 I want to rewrite as a 3. So that's going to be 3 squared. And then that log property says bring that 2 down in front. Now, if I didn't have those decimal approximations, I'd be done at this point with this problem, but we can substitute in that 0.5 and that 0.7. So we end up getting 1 plus 0.7, which of course is 1.7. Okay, so that was a lot, perhaps a little bit too much, but do know that when I'm back on Thursday, these are going to get reviewed because we're going to be solving equations. And when we start to solve equations, more complicated log equations, that is, the properties can help us. So what do I mean by that? Well, look at like 8a. What if that equals a number? We're going to be able to do stuff with that. So this is just a stepping stone to get to other stuff. Your homework is a little bit of the properties, put them together and take them apart. And then also a little bit of this stuff that I kind of started with up here. So things that you could think about from what we did last week. All right, hopefully homework goes well. If not, I plan to be back on Thursday for St. Patrick's Day. If you're wondering why I'm not there, I am celebrating my birthday away from school. So I will see you back on St. Patrick's Day. Have a wonderful Tuesday and a great week.